Humanity knows destruction. We've learned how to split the atom, creating forces that can level cities in a blinding flash. The most powerful weapon we ever detonated released energy equivalent to 50 megatons of TNT. To us, that is apocalypse-level power. But out there, in the deep cosmos, our biggest booms aren't even a firecracker. They aren't even a whisper. The universe is a violent place. It operates on scales of energy that our primate brains can barely comprehend. We are talking about events that vaporize entire solar systems in milliseconds. Explosions so bright they can be seen across the entire observable universe. Today, we're leaving safety behind. We are going hunting for the true monsters of the dark. These are the scariest explosions in the cosmos. Let's start small. Let's start in our own backyard. Our sun seems reliable. It gives us light, heat, and nice beach days, but it is also a massive fusion reactor that occasionally throws a temper tantrum. These are coronal mass ejections. Basically, the sun sneezes out billions of tons of superheated plasma, moving at 1,000,000 miles an hour. When a big one hits Earth's magnetic field, it's chaotic. In 1859, the Carrington event hit us. Telegraph wires burst into flames, and operators got electric shocks. But that was 1859. We didn't have a global electrical grid. If a Carrington-level event hit today, it wouldn't just be pretty auroras. It could fry satellites, collapse power grids globally, and take down the internet for months, maybe years. No power, no GPS, no banking. It's an explosion that sends civilization back to the Stone Age overnight. And it's not a matter of if it will happen again, but when. But the sun is too small to do what comes next. For a real cosmic explosion, a star needs to die. Imagine a star 20 times more massive than our sun. For millions of years, gravity tries to crush it, and fusion energy pushes back. It's a perfect balance, until it runs out of fuel in less than a second. The star's core collapses from something thousands of miles wide into a ball. It's 12 miles across a neutron star. The outer layers of the star, billions of trillions of tons of gas come crashing down onto this hard new core, and they bounce hard. This is a core collapse supernova. For a few weeks, this single dying star can outshine its entire galaxy of hundreds of billions of stars. If a supernova went off within 30 light years of Earth, the radiation would destroy our ozone layer, leaving life on the surface to be fried by ultraviolet light. Thankfully, no stars that close are ready to pop. But some stars don't just explode in all directions. Some take aim. Imagine taking the energy of that supernova we just talked about to all that power, and instead of letting it spread out everywhere, you focus it into two tight, laser-like beams. This is a gamma ray burst, or GRB, the most luminous electromagnetic events known to occur in the universe. GRBs are the universe's sniper rifles. They usually happen when a massive, rapidly spinning star collapses into a black hole. If you aren't in the path of that beam, you might not even notice it. But if your planet is looking down the barrel of that gun, it's game over. A close-range GRB wouldn't just strip the ozone layer. It would blast the atmosphere with enough radiation to break apart nitrogen and oxygen molecules, creating a thick smog of nitrogen dioxide that would block out the sun and acidify the oceans. The scariest part, we wouldn't see it coming. Gamma rays travel at the speed of light. By the time we saw the flash, we'd already be hit. We are getting into the truly absurd territory now, the stuff that keeps astrophysicists awake at night. You have hypernovae supernova on steroids. But my personal favorite nightmare is the magnaire. Remember the neutron star left over from a supernova? Sometimes, they have magnetic fields 1,000,000,000,000 times stronger than Earth's. And sometimes, their crusts crack. Starquake. In 2004, a wave of gamma rays from a magnetar explosion hit Earth. It came from 50,000 light years away. It released more energy in 1/10 of a second than our sun releases in 100,000 years. And that was just a little crack in its surface. These events are terrifying. They remind us that we live on a fragile little rock, drifting in a shooting gallery. But there is one explosion that beats them all. The one that started it all. The Big Bang. It wasn't an explosion in space. It was an explosion of space Every massive event we see today is just a tiny aftershock. The universe is violent, yes, but without these explosions, we wouldn't be here. The iron in your blood, the calcium in your bones, the oxygen in your lungs, it was all forged inside these dying stars and blasted across the cosmos. We are made of star stuff. We are made of the debris of the scariest events in the universe.